All right, well, it's 9 o'clock, so let's go ahead and get started. Small crowd today, but that means we probably have more time to actually talk through some things. If I get done a little bit early, we'll have some more time to talk through various workflows. Because what we're here today to talk about are Git workflows that work. If you've ever used any kind of a version control system, you'll know that there are infinite ways that you can structure your code, infinite ways that you can try and put releases together, try and structure your branches so that you can always find what you're looking for. There are lots of ways. Some of them work really well, some of them don't work very well at all. A little bit about me. My name is Ben Loveridge. I work at a small company called GradeCam. We make software used to make teachers' lives easier when they're grading tests for kids. You can find me on GitHub at Loveridge, and most places I try and use Loveridge, but turns out there are more people with the last name of Loveridge and the first initial of B, so when I can't use that one, I use Terminon, and that's where you'll find me on Twitter. If you want to follow along, you can use these URLs to get to the slides. This is going to be a live slide deck that will progress as I progress, or you can just go and get the actual slides there if you want to download those and look at them later. And all of these are going to be linked on the joined in page, so if you want to download the slides later on or reference them later, they'll be there for you. And you can please leave feedback after we're done at joined in so that I can find out how to improve this for next time. So let's get started. We're going to talk about using Git. There are lots of version control systems. There are lots of good things about lots of them, but we're going to talk about Git. Code is king, and what I mean by that is without our code, our companies don't really have much to show. I mean, we have lots of good talent, but our code is our product. What does it cost to develop software? Generally speaking, it costs a lot more in developer time than it does in branching. Branching in Git is really fast. That's one of the great things about Git, is that if you want to try something new, you can create a branch, you can throw some stuff on there. If you don't like it, you can throw it away, you can start over. Basically, a branch is about 40 bytes. That's how long the SHA commit reference is. A branch is just a named reference to one of those. It says, hey, my branch called dev testing or new feature is pointing at this one commit. You create new commits, that thing rolls along with you. Whereas developer costs, well, there's all the time that goes into learning how to do this stuff, into coding it, into testing it, into everything else. But if you don't have a good branching strategy, it'll end up costing you a lot more because your expensive developer time is going to be spent on trying to figure out where the crap is the code, what happened to it, where's our release, what's good, what's bad. So if you don't know how to keep track of your code, it's really going to end up costing you. So it makes a lot of sense to come up with a strategy that works. Let's talk about some of the more common patterns for branching that are out there. We're going to talk about 3 of them. The first one, everything goes onto master. You don't branch anywhere. Maybe it's just you and a buddy, but you just throw everything on master. Well, the problem is, what's good? You don't really know what's good. What's the last thing that was deployed? Who knows? Because we've just got one branch. We might not even have any tags saying this thing went out. Hopefully we have at least that much though. If you make a mistake, everybody else is broken because they're all working off of the same code. They haven't had a chance to integrate with your broken stuff, or they tried to integrate with your broken stuff and hey, it broke them too. It also leads to big commits because you don't want to be that guy who breaks everything. So you'll start working on some feature and you'll go and touch 20 files and make bazillion changes, and then you'll throw them into master when they're all safe because hey, this way I'm not going to break anybody. But the trade-off is you've now got this massive commit where if there's a bug in there, it's going to be a lot harder to track it down. I'm a big believer in small commits. A very poignant example of why I do that is I was working on a project a few years ago. It was a media player for, it ran in WebKit. We had a desktop application that ran inside of. If you've ever worked with multiple browsers, you'll know that you make one change somewhere that looks safe and it breaks IE, or it breaks Firefox, or it breaks Chrome. Sometimes the browser will update and all of a sudden your site that was working before is now broken. This happens a lot with Chrome specifically, and more recently Firefox, because they're rolling updates a lot more frequently. Well, we'd been working on some feature. I deployed something, it had been out for months and working great, and then the new version of Chrome comes out and all of a sudden the site's broken. So what in this code caused the breakage? So I started using the Git bisect tool, which if you haven't used it, I really recommend looking into it because it can help you track down bugs really quickly. So I started bisecting my code to find out where did it break. And what I found was there was one style sheet change that had been made which the new version of Chrome didn't like the way that we had done that. Fortunately, the commit that introduced that change only changed that file, and there were only a few lines in that file that had been changed. So tracking down which of these changes actually caused the problem was really quick, because I didn't have to look through really large commits, which if the commit had been 20 files and 20 lines per file, finding out which actual line of code caused the problem could have been a lot harder. So leading to big commits can end up costing you a lot. And let's be honest, if you're doing this, you're probably branching without realizing it, because with Git, you commit locally and then you push. Anything that you commit locally before you push, you're essentially working on your own copy of the master branch, your own branched version of that, because when you try and push it, well, you have to merge. You only merge when there are multiple branches. So likelihood is you're branching anyway, kind of, without even realizing it. How about another one? We've got branch per release. I've seen this one lots of times. You've got 4.1, 4.2, 4.3, 5.0, whatever it happens to be, and each of these releases has a branch. There's some really nice things about that. You always know what's the latest version of 5.0 because I've got this branch for it. If I need to go make a change on 5.1, I've got that branch. I can go and I can make that change to 5.1. But where do your fixes go? Say you've got 5.1 released and you've got this special branch for 5.1, but you've also got your development branch for your next 5.2 or 6.0 release. There's a bug in 5.1. How do you get that fixed in all the right places? Because the fact that it's in 5.1 means there's a pretty good chance it might be in your development code too. So do you fix it on your development branch and then cherry pick it into your release branch, or do you do the opposite way around? So what's the right way, what's a clean way of getting those fixes where they need to go? And also it leads to this. I mean, there's just branches all over the place. And I don't know about you, but when I'm working on something, I like to look at what branches I have to find out what I'm supposed to be working on. And when there's tons of releases everywhere, that just pollutes it. It makes it take longer to look through and find the meaningful stuff. So there's just, I like not having tons and tons of branches everywhere. And then this one I think is my favorite. We've got 5 developers on the team. Everyone has their own branch. You might be jumping around working on other stuff today than you are tomorrow. That's where it starts, one of the places where it starts getting really painful, because you're working on more than one thing at a time. And if you've got a developer branch, well, likelihood is these are going to be long-lived branches because, hey, I'm still working here. I've been working here for a year. I've got my branch and it's been here for a year. Well, now we've got this extra branch that we all have to integrate with whenever we do merges, and that leads to merge hell. Have you ever seen a tree where you can't even find the commits because there's so many merges? The tree is so wide, so fat from all the times you've had to merge these branches in, it just becomes really unmaintainable. So what do? What is a branching strategy that is sane, helps you get your code out the way you want it to, helps you know where your code is supposed to be, helps you know what you can trust? But in order to answer this question, you have to ask yourself this question. When do you typically release? What do your release cycles look like? Do you release every day? Do you release multiple times a day? Do you release every couple of weeks? Do you work on a bunch of features, vet them, then integrate them together, and then ship them? The answer to this question really can influence, and should influence, what kind of a branching strategy you want to set yourself with. So I'm going to talk about 2 of those today, one for each of those 2 release strategies. The first one, if you've got planned releases, is Git Flow. I've got some links here at the bottom that you can find some more information about Git Flow, and we'll talk about Git Flow and the way that you use it, and these resources will also be on a slide at the end, slide at the end of the deck. So Git Flow is a bit more involved than some people think is necessary, and in lots of cases it really is, because it really depends on what are you trying to accomplish, what is your release strategy going to be like. But I've found, and I've been using Git Flow for about 5 years now, that Git Flow works really well if you have releases that you want to do at various intervals, or if you have multiple versions that you might need to release, that you might need to maintain for a while. Ideally, in my mind, you have one version that you're maintaining and supporting. But sometimes the sad truth of life is you've got customers who are using an old version, and it takes them a little while to upgrade to the newer versions, and sometimes they have to have fixes done. Git Flow accounts for that in clean ways so that you can keep your code maintainable but still know where stuff goes. The second one, if you want to work on a continuous release style, is GitHub Flow. It's much simpler. There's really only 2 kinds of branches involved. The philosophy here is I'm going to work on something, I'm going to get it done, I'm going to release it. I'm going to work on something else, going to get it done, I'm going to release it. So let's go into a few more details. Let's talk about Git Flow. Just take a moment to absorb it in all its beauty. It's not really as scary as it looks. That's one of the things that can sometimes get people a little bit scared or nervous when they start looking at Git Flow is, well, look at all those branches, look at all these commits, how do I really know where anything goes? It's not really that bad, and I'll show you how. There are a few types of primary branches in Git Flow. Where am I doing my development work? Where does that stuff land? So what's my last set of good development code where I should start new features from? The second one is, well, where do those features go? How do I develop those features? And the last one is, what's my production code? Because we want to still be able to know at all times what is deployed, what's out in the world, what is the developer's version of reality, what is the customer's version of reality. Now, because there are other things that you have to account for, like, for example, you've got older branches, you've got older versions that some customers are using, we might need to provide some support for those. Well, there are also times when you're going to find that as much as you tried, there was a bug. I'm sorry, there's a bug on production and we have to get that thing fixed. And we also want to make sure that we don't have that same bug in our next version. So how do we do a hotfix correctly so that the code gets both in our current version and in our new versions without having to do a bunch of cherry picking it from here to there and just trying to come up with it ad hoc and making sure you've dotted all your I's and crossed all your T's. And then of course, we got to make sure that new releases get out. So sometimes we use an extra branch to help with that. There are only two long-lived branches though. There's your development branch and there's your release branch, your production branch. Every other branch, you go to do some job, and when that job is done, you come back, you merge it in. Let's talk about the elephant in the room, branch naming. If you've looked into Git Flow at all, and if you haven't, if you do start to look into Git Flow at all, you'll probably see that there's kind of a hot debate about branch naming. If you look at the original article that Vincent Dreesen put together that proposes Git Flow, this was back in 2010, he calls his development branch develop and his production branch master. Well, as you know, when you clone something by default, you're going to pull down the master branch. And so that means to a developer is when you clone the repository as a new developer, all of a sudden you're getting the customer code, not the developer code. So you've got to go and check out a new branch, get everything set up so that you're actually working on the right code. Because if you create a branch off of master, you might be working on a feature that's already done. You might be working on bugs that have already been fixed. And it's just not where you want to be. And so people have gotten hung up on the fact that, well, he's calling master the production branch. I don't want my developers to be working off of master. I want them to be working off of, I don't want them to be working off of the production code, rather. I want them to be working off of the development code. But really, at the end of the day, these are just task names. They're the purposes that the branch serves. One is a development branch, one is a production branch. You can call it whatever you want to. I prefer to call my development branch master because when my developers clone the code, I want them to have the development code so that they can go branch off and start working off the right set of code without having to take any additional steps. We call our production branch release because that's the released bit of code. We've thought about calling it production in the past or other things, and you could rename those if you want to. It doesn't really matter. At the end of the day, what matters is, are you using the right type of branch for the right type of purpose? Call it whatever you want. By no means should you feel like you need to go and find some different branching strategy because Git Flow recommends you use develop, which people have done. They've gone and said, oh, well, I don't want to use master for my development branch, so here's a new branching strategy. That's unnecessary. If Git Flow doesn't work for you, then Git Flow doesn't work for you, but it shouldn't be because of the names. For the purposes of this discussion, we're going to keep things simple and just call them development and production. We're not going to try and get argumentative about anything here. So there are a few tasks that you need to perform as a developer. The first one is feature development. So what happens here? We start out on our master, our development branch. We go out, we work on some feature for a while, we make some commits, and when we're done, we come back in. Usually, hopefully, this comes with some kind of a pull request or some kind of a discussion to make sure that your code looks clean, that it's been well vetted, that more than you has bought into it. Whatever that process involves, you've got some kind of a structural or formal buy-in before you go ahead and merge that in. If you're using any kind of a tool like GitHub or Stash or GitLab, Pull requests work really well for this. That's what we do at my company is you work on a feature, you make a pull request to get that merged in, you go through the discussion, and when you come back in at the end of the day, you're going to have a merge commit. This, I think, is very valuable. Some people like to have flat directory structures. Flat commit trees. I prefer to have the visual branching out and branching back in so you can see what code would work together as a group, because that can help get you some insight into what problems did they think they were trying to solve as this. You can see really, it helps me visually to compartmentalize the code and the related changes as what they're supposed to be. So I like to do that. Now what does this look like in terms of Git commands? This is again where some people start to get scared when they look at Git Flow because it looks like a lot of commands. But basically, I mean, it's not really anything special. You create a new branch off of development. You work on it. When you're done, you check out development and then you merge your feature back in with the no fast forward flag. If you're doing it from the command line, this is the thing that gives you that merge commit as opposed to the flat commit structure. If you're using GitHub or GitLab or Stash pull requests, they're going to do that for you by default. There are usually flags where you can turn that off, but that's going to be the default. And then when you're done, because you want to be a nice developer, you want to play nicely, you're going to go ahead and you're going to delete your feature branch.
What do you mean by the flat?
Flat? Okay, so let's, actually I got a slide for that. If you are working on, where did it go? So you've got a feature right here that you've been working on. You've done 3 commits, and then you're done. You want to merge it in. If you just go onto your development branch and you say git merge this feature branch, by default, Git is going to say, oh, well, there were no other changes here in the meantime, so your master, your development branch was right here. It can say, oh, well, this is a direct child. There's nothing in the way. I can fast forward my pointer to here. So that's what happens over here. Your development branch was right here. You had these 3 features. Now your development branch points to this commit. You've lost the context that this all happened on a separate branch. Your history doesn't show that. It doesn't care. It just says, I've now got these 3 extra commits in my repository. So I call this the flat commit tree. This one, you can see it went out, they worked on a separate branch, and then it came back in. This one here says merge feature cart into development. Does that answer your question?
Yeah, no, there had been a change on develop in the meantime. That wouldn't happen? Or?
Right, so if there had been a change on develop, and you were just using raw git merge, what it would do is it would create that merge for you. And if there were any conflicts, it would put you into conflict resolution mode, because Git is going to say, you want to add these commits, there were some other changes, I can't just fast forward. It'll try and do a clean merge if possible. If not, it'll make you do a conflict resolution step, but you will end up with a commit there at that point.
So flat means I lost the notion that there was a branch.
Yes.
Fast forward, some of the terminology I've used a lot of other source control, I haven't used Git much, so I'm trying to...
Okay, so fast forward is just Git's default merge strategy. It will always try and fast forward if it can, because it wants to avoid merges as much as possible.
Fast forward is the strategy that tries to do
this. Yeah. The fast forward merge strategy, which is the default merge strategy, tries to keep things as flat as possible. So we are explicitly telling it, I don't want you to do a fast forward merge. I don't want to lose that context. Which is, again, what happens when you do a pull request on any of the popular version control softwares. So if this looks scary, I'd like to let you know that, well, A, it's not that scary. And another thing that I've encountered in the past with people being introduced to Git Flow is they've seen people doing examples where they say Git Flow feature start X, and they feel like Git Flow is now an extra tool that I have to use to manage my version control. That's not true. It's just raw Git. It's just a bunch of commands. There are tools like Git Flow AVH, which people use in those examples, which make this a lot simpler. You can say Git Flow feature start cart. That will go and it will check out your development branch for you. It'll make sure it's up to date. It'll create your new branch for you. It'll put you on that branch. But you can do the same thing with vanilla Git. When you're done, you can say Git Flow finish cart. That will do the merge. It'll do the no fast forward flag for you, and it will delete your branch. Again, there's nothing magic here. It's just making it fewer steps for you as a developer. So Git Flow is a helper. It's not by any means a requirement of Git Flow. So if you're hung up on the fact that you don't want to use Git Flow because you don't want to use a tool, you don't need to be hung up on that. That's just a convenience helper that people have made for you. I like to use it, but generally I only use it for preparing releases and for doing support, because I do my feature branches either with raw Git or going through a pull request. At the end of the day, doing a pull request on GitHub and merging it is the exact same thing as this, except for you have to go and delete the branch afterwards for yourself. Yeah? What Git Flow is doing, Git Flow is a script. Are you familiar with the way that Git subcommands work? Okay, so Git subcommands, if you have a program on your system called git-tyler, and you say git space tyler, it will run that script with whatever arguments you've got. Git Flow is a Git script like that. It's called git-flow on your system in your path somewhere, and it's saying, when I'm executed, take whatever arguments I have. Oh, okay, I've got the feature argument, so let's go into my feature fork. What am I trying to do? I'm trying to finish cart. So let's find the cart branch, the feature cart branch. Let's try and merge that into our development branch. If that works, great. We're going to delete that branch and leave you on your development branch, and we're good to go. So Git Flow is just running those raw Git commands. If you go and look at the source, you'll see where they have run this Git commit, run this Git merge with these flags. So really all it's doing, it's a bash script that runs extra Git commands for you. So you run one command and you get 5 run for you.
Like the feature start would be like a Git checkout branch.
Yeah, so Git Flow feature start, it tries to make sure that you're on the most recent code. So it's going to actually do a few more steps than what we showed. It's going to check out your development branch. It's going to say, am I behind origin? Do I have commits that I should have? And if you do, it's going to say, you're not up to date. Let's have you go ahead and update your development branch first. Then you've done that, you start again, it's going to say, okay, you're now good. You don't have any code that you're missing, so you're working on the right version of truth. You're not going to step on somebody else's toes. You're not going to be fixing something somebody already fixed on the development branch. And then it's going to create that new branch for you and check you out on it. Any other questions right now?
Yeah, so you mentioned the fast forward. You're also deleting the branch. Are you deleting the history of the development of feature?
No.
By having it separated and deleted?
No. So that's the point of doing this step right here. And maybe I don't remember if you were in when we talked about this. So by the fact that we're doing the no fast forward flag, we're keeping all the information that this happened on a separate branch. You're always, even if you do a non-fast forward, even if you do a fast forward merge, you're always going to have these commits and their messages. But by doing the no fast forward flag, you preserve that bit that says, hey, this happened in isolation. This happened by itself on another branch, and hey, this is what the branch was called. So that can help you reference which issue in your issue tracking system it was relating to and so forth. Other questions? Okay, let's move along. So now I want to prepare a release. What's that look like? Well, it didn't move. It's behind. There we go. All right. Sometimes when you're using WebSockets, things take a little bit of time. Okay, so we start out on our development branch. We check out a new release prep branch. Here's where we do stuff like, if we have a version, say we have a package JSON file and we need to bump the version to match. We'll do that in there. Anything that you do as part of your, I'm going to release this, I need to bump version numbers and so forth, you'll do that here. When you're done, you're going to merge your release branch, your release preparation branch, into your production branch. Production now has all of the code that you've been working on your development branch and all of your version changes, etc. You're going to move that up here. Generally, you're going to tag this, and if you're using Git Flow, it'll do that for you. It'll tag that version, and then you merge that back into development. This is a little bit different from what you're going to see if you look at the Git Flow documents that Vincent Driesen put together initially. What he's going to show you is you've got this release prep branch, you merge this up here, and then you merge this down here. We don't do that, and that's not the way Git Flow AVH works, because it breaks one of the nice features of Git, which is git describe. If you're familiar with git describe, it's a command that you can run at any commit point, and it will tell you what is the most recent tag you can find if you look in my history. So if you're here, and you've tagged this 4.0, and you say git describe, it's going to say you are on 4.0. If you were on the next, say there was another commit, which we're not going to do, but say there was another commit here, it would say, oh, you're on 4.0, but you're a commit ahead. If you merge this down into your development branch, but you tag this, if you're on here and you say, what is my most recent parent, what's my most recent tag? If you ask Git describe, well, this tag isn't a parent, so it's never going to find that. So by merging the tag, the production branch into your development branch, and you say, hey, Git describe, what's my most recent branch? It's going to say, oh, 4.0, and you're one commit ahead because you've got the merge commit right here. So that was a change that was proposed to Vincent Dreesen several years ago by me, and he stopped maintaining his version of the Git Flow tool, but Git Flow AVH, which I've linked to, is a more maintained version. They're actively maintaining it. That's the default strategy in Git Flow AVH, because the point of Git Flow and the point of using no fast forward in the first place is we want to preserve as much history, we want to preserve as much contextual information as possible. So being able to tell when you're developing, what am I developing against? I'm developing against some offshoot of 4.0 is very useful. So we just talked about that. So what's that look like in Git Flow? Well, if you're using the tool, then it looks like this. You say start 4.2.2. That's going to say, okay, let me go and make sure that the branch has all the latest code, make sure that there's nothing missing on development branch. It's then going to create a branch for you to prepare 4.2.2. This is where you're going to update your package JSON with your 4.2.2 version, whatever that happens to be. At my company right now, we don't actually maintain version in a separate file. It's just tag based. So we don't do anything here. We just say, okay, start the branch. When you're done there, you say, finish the branch, finish the release. And that performs the steps of, it merges it up into into your production branch for you. It creates a tag called 4.2.2, and it asks you to give it a message, so you can use that to describe what features have come into 4.2.2. So if somebody ever wants to just go and say, hey, what is 4.2.2? They see that information there, and then it's going to merge that down into your development branch, so that the next time somebody goes to check out, they've got all the release code, they've got the version in their Git describe history, they're good to go. But again,
So would it be a step that would automatically number that for you 4.2.3, or do you just manually do that?
you manually do that. You specify what version, because Git Flow doesn't make any assumptions as to what your versioning scheme might be. So you just say, I want to create a version called X, and it will go and find whatever it will merge that into where it needs to go, but it doesn't know or care what version might have been there before or might come after. This one looks, again, a bit more scary if you're not using Git Flow, but you can see there's not any black magic going on here. These are steps that you can perform by yourself, and I've done these steps myself many times. If you can't get Git Flow working, or you just don't have it set up, you're working on, say, your home computer because you left your work machine at the office, whatever it happens to be, and you don't want to deal with it, you can do all of these steps with vanilla Git. There's nothing really scary as long as you understand what's going on here. So what if there's a bug? We've now got a problem where there's something that we released on 4.2.2 that is bad. So we can see that we've got some previous version, we've got some previous development code. We're still working on preparations for the next version, but there's a bug here. So how do we fix that bug and get the code to both places? We create a hotfix branch, which comes off of our production branch, because that's what's out there. We want to fix this for the customer. So we come and we fix that here, and then we say, okay, I'm done with that. It's now fixed. We can make 4.2.3, and then we can merge that back down here. All these fixes that we've done come down and land in our development branch. So we can now make sure that not only do our customers have the bug fixed, but the next time a developer is working on something, they don't have to go and fix that bug for the next release. You don't fix it down on development and then cherry pick it up in here and hope things work. You fix it where the problem actually is, and then you merge it down into your development branch. Now, are there any questions before I go on? Sometimes that happens. Sometimes you might have already fixed the bug on development. So if that happens, then you'll just have to deal with that merge conflict when it happens. So it really all depends on your code flow. In many cases, this is going to work just fine, but you will undoubtedly run into a scenario where it didn't. You have to deal with a merge conflict.
Does that mean if you had already fixed it in development, you should still do a hotfix branch of production?
What I would do in that case, and I've done this in the past, is I would still go through this scenario, but this commit would have been a cherry pick, because that's going to cause me the least likelihood of causing the same, or of having a merge conflict when I come back into development. Say this commit here fixed the bug, but then we found out, oh, a customer is experiencing this. We thought that they couldn't get there. We thought that it wasn't a big deal, but now they're complaining. But I've already got it fixed. So you can create your hotfix branch, cherry pick this thing in, and then when it comes back down to merge into your development branch, that's going to apply cleanly because the same commit has already been done. The same change set is already in the history. So there are lots of ways that you can tackle that one.
But most of the time, this won't happen simply because you should always be pulling down from your production on a regular basis, correct?
Well, you're ideally not committing to your production branch unless you're actually doing a release. So this shouldn't happen unless you're really, I mean, if you're unaware of the bug, this should work fine because you found the bug in production, you probably didn't already find it in development, and so once you find it, you fix it in the appropriate place. You fix it for the customer, which also fixes it for the developer. But again, sometimes that's not the case. Sometimes you did know about it, but you didn't think it was a big deal. Or sometimes it might be even more complicated. Maybe you fixed it as part of a refactor and you didn't realize it. So those are the times that this might work. But generally, you should never be committing onto your release branch because you don't want to be putting commits in that might belong in other places too. So what does this look like? We say hotfix start 4.2.3. What that says is go find my production branch and make a new thing based off of that called 4.2.3. You then fix your bugs, you do whatever you need to do, and when you finish it, that does the bit of merging it both directions. So you keep that git describe history that tells you where things are going, what your lineage is. And in raw git, that looks like this. You check out a hotfix branch based off of production, you do your commits to fix it, and then when you're done, you merge it around. You give it a tag, you merge that tag in, and you're done. So you can tell here when we merge, we're merging the tag which we did off of production. So that's how we're getting our git describe history clean, because we're merging that tag in. Sometimes you have to support old versions. Ideally you don't, but sometimes you do. So we're going to focus on just this top portion. I've got this bottom portion here just to illustrate for you what might be happening on the rest of your code. You might have people who are working on features, preparing for a new release, whatever it happens to be. This old version, though, that you have to maintain, someone found a bug on. You don't want to, that's not your flagship version anymore. Maybe this is 3.0. It doesn't look like it because we've shortened the log down to something more meaningful. But you've got this thing that you kind of have to support, unfortunately, but you don't want the support or the changes from that to interfere with your development in any way because you've gone a different direction now. Those changes aren't applicable to the new way that your code is going. So what that looks like is you say, okay, let's go find that old version, which you're going to have a tag for it. You're not going to have a branch for it, but you're going to have a tag for it. So you're going to say, go find me this 4.0 or 3.0. Say this is 3.0. Go find me 3.0 and make a support branch off of it. You're going to commit those fixes there, and that's where it stops. You don't put those commits anywhere else because you've gone a different direction with your code. Maybe that feature is obsolete. Maybe that feature has been rewritten. At the end of the day, the point is fixing the feature or fixing the bug for that old version has no bearing on what you're working on right now, so you don't want to conflate your code with those commits. So you just say, basically, they become orphans. What's that look like? You say, I want to start 1.8.6 off of 1.8.5. You then commit things. If you want to, you can tag it. You can leave the branch around if you want to. I try not to. Some people like to leave the branch around because it feels like it's not a dead end anymore if they need to go back to it. But the tag accomplishes the same thing for you. You can always go and check out a tag. At the end of the day, if you look in your, say you're using GitX or some other kind of a code visualizer, a commit visualizer, you'll see that these things go out somewhere and then they stop. They don't go anywhere. That's fine because they're not supposed to go anywhere. This one doesn't really look any different in raw Git. I guess I had my alignment off there, I'm sorry. But the only difference is we change flow support start and the names of those commits that we want to deal with, the tags, to I'm going to manually specify the name of the support branch and the tag that it's supposed to be on. Really, it's the simplest kind of a rewriting or helper that you get from Git Flow AVH, and hopefully you're not doing these very often because you're able to keep customers or servers on the newer versions. Questions about Git Flow before we move on to the next one?
When you do the Git Flow, you already lead on your branch to check out from?
So Git Flow, when you download the tool, you can initialize your repository for Git Flow. it doesn't care what branch you're on. It doesn't care what branches you have. What it's going to do is it's going to run you through a series of prompts and say, okay, what branch do you want to use for your development features? What branch do you want to use for your production releases? And then it will also ask you what kind of a branch prefix do you want to use for feature branches or for support branches or release branches. It calls a release branch what I've been calling a release prep branch. I've been using release prep because I don't want to confuse it with the purpose of maybe your released code or whatever else. But it's going to ask you, and so you'll see this support slash. That's the naming convention that I use. You can set up Git Flow to use support dash or S or whatever you want to. And it will just ask you those. And then when it's done initializing, when you're done answering all those questions for it, it'll make sure that those branches are all checked out, that they're to the right version of code, and then you'll be ready to go with Git Flow feature start X. Other questions?
Maybe I missed this at the beginning. Git Flow, Git hyphen Flow, Git hyphen Flow hyphen AVH.
Git hyphen Flow hyphen AVH is just what it's referred to because it's not the official original Git Flow tool released by Vincent Dreesen, but it's still just going to be Git-Flow on your system. So you're just going to use Git Flow feature, whatever it happens to be. I've got the URL for the GitHub repository at the end of the slides, but the name of the repository is just Git Flow. There's no hyphens or anything on the GitHub repository name. So I use Git Flow AVH so that if you're going to Google it, you're going to find the right thing.
And where did that come from? And
where that came from is, and I think I mentioned this earlier, but I don't remember if you were here or not at that point. Git Flow is a workflow that was proposed by Vincent Dreesen back in 2010. He then created a set of bash scripts to do these commands like this for you in 2012. But shortly after he released that, he stopped maintaining it. He stopped working on it. So if there were bugs with it or proposals to make the workflow a little bit better, like for example, merging the tag into your development branch so that you can keep that Git describe history that we've been talking about, he never got around to any of that. And so Git Flow AVH came as a result of people saying, you know what, we want something that's maintained, we want something that continues to evolve with people's workflows, and if someone has a suggestion, we can actually merge that in and make it so that it's usable and people don't have to make those changes themselves or make their own forks, make their own patches. So Git Flow AVH just came as a result of the original Git Flow tool not being maintained anymore, and they wanted something that was.
so it's like a community
Yes.
tool that was all on.
That's right. And they accept pull requests. They've been very responsive to that kind of stuff. So yeah, it's just a maintained version of the Git Flow tool. Other questions? All right. Well, let's go on to Git Flow. Like I said, this one's a lot faster. There's a lot fewer things going on here. There's a lot fewer moving pieces. And the reason for that is because the kind of a release strategy that this works well for is continuous release. I want to develop stuff and push it out. Develop more stuff, push it out. So basically this is the workflow. You have your master branch. You want to work on something, okay, you go and you create a branch for it. When you're done with that, you make a pull request, you get whatever testing, vetting, discussion, buy-in needs to happen, and when you're done, you merge that into master and you're good to go. There are only two types of branches. There's your master branch, and there's your feature branches. If you're making another branch, then you can have prototype branches if you want to. You can have testing branches, whatever you want to. But the only branches that actually matter to the workflow are whatever the version of truth is and whatever the version of what you want to work on is, whatever feature you're working on. And it looks simply like this. You create some branch off of your development branch. You come over here. You create whatever commits you need to. You open up a pull request. Here's where you have discussion on the pull request. You might make some additional changes as a result of that discussion. And when you're done, merge it, deploy it, you're done. So when you want to prepare a release, there's not really anything to do because you've already done that. So it's a very simplistic workflow, but in many cases, this is going to work great. If you're deploying every day or a couple times a day or maybe even every couple of days, this might work really well for you because you don't need the extra overhead of maintaining old versions. Kind of maintaining old versions doesn't really work in this case because where's it going to go anyway? You're only deploying one version. This works well if you have your own code. Maybe you don't have customers who integrate with versions of your code. You don't supply this as a product to other people. That's one of the times that this might work. That's really all there is to Git Hub Flow. Any questions on that one? Okay, well, then let's have a bit of a summary. Some of the pros and cons of Git Flow. You always know where your production code is available to you. You know where bug fixes belong. You know how to get things from A to B to C. You know there is a place for everything and everything in its place. You know where I should go to put in this kind of a thing, where I should go to put in that kind of a thing, and good confidence that if you're following the system, it's not going to get lost. Your hotfix is going to get into both places because the workflow, the branching strategy encourages that, and the tools enforce that. And so, as a result, you can also support multiple versions because, well, hey, you've got that tag, you've got that old thing out there, you've got a pattern for doing that and not having to make it up as you go. Obviously, there are some cons, though. You've got multiple branches that are long-lived. And if you're sloppy, that can cause you problems. I've worked on teams in the past where they had a habit of committing things directly onto the production branch. And then when they tried to perform the next version, oh, well, now I've got to solve merge conflicts on my production branch. That's a discipline problem. That's just a matter of you not following the branching strategy the way that you're supposed to follow the branching strategy. It can look like a lot of steps because, I mean, the number of commits it takes to create a hotfix branch is a lot more than it takes to open up a pull request, to open up a new branch, create a pull request, and merge it. And as a result of this, it can feel a little bit slower and a little bit less agile. You're not releasing all the time. You might have to go and work on old code sometimes. Sometimes that's the world you live in. Sometimes you have to be able to support those things. You can still do this quickly. Like I say, I've been using Git Flow for about 5 years. We're using it at my current company. We do have more of a measured release cycle. We have a release every week or two. And so it makes a lot more sense for us because we can still get our code into development and not have to worry about, now because it's continuous release, it's going to get shipped out there. We don't have to deal with that. We are still able to do our feature branches, our feature work within a day or two, so people are still integrating quickly and often, but it can feel a little bit slower, or a lot slower in some cases than GitHub Flow. So GitHub Flow, it works really well if you're deploying early and you're deploying often, because as soon as you finish a feature, it's supposed to go out there. Because of that, you're integrating all the time. If you worked on something today and I'm working on something today, you release it, it gets pushed out, well, I'm going to have to integrate with that today because I want to finish my feature today. So you are going to be integrating a lot more, potentially. And you don't have to have any kind of helpers to keep it simple. You can use this all in vanilla Git with git commit, git push, and git merge -- no fast forward if you want to keep that same kind of a feedback loop with the fact that your code came in off of a different feature branch, which if you follow their procedure of using a pull request, you're going to get that anyway. It's very simple. But as a result, you sometimes have to do some weird things. Like say you're working on a feature that's not quite ready, but you need to start working on something else. You don't want to have this thing stick around and have to wait for integration later. Well, maybe you put a feature toggle in your code that says, this feature's there, but it's not really available for production yet. So you're sticking some code into your deployments to turn off features that are part done because you didn't have a chance to finish them or because they still need to take more time. And some people love that, some people hate that. It's just something that you might have to deal with if you're using GitHub Flow, for better or for worse. And as we've talked about, you can't really support multiple versions with this. So if you've got old customers that you need to maintain, it's a lot harder with this because, well, now you've got a new kind of a workflow you have to come up with. How do I go and find that old version and get them a new version of code that's meaningful to them? You don't have any guidelines to help you do that, so you'd be kind of on your own at that point to make it work. So that's what I've got. What questions do you have that we haven't already answered? Yeah. I just use Vim. So in your git config file, you can specify what tools you want to use for conflict resolution, for doing diff merges and so forth. And I've just told it to use Vim diff. So whenever I get a conflict message, I just say git merge tool. That launches Vim for me with the various versions and my one copy to go and modify. And when I save the file, it recognizes that the file handler changed and it deals with that appropriately. So personally, I use Vim diff.
So, just for concrete examples, what would you use for the operating system? What would you use for a database? What would you use for an application? What would you use for a web service?
Okay, so for a web service, I would probably use GitHub Flow, because that's likely something that's going to be running on my own system. I've got full control over it. I don't need to support other people running that, so I don't need to support older versions, and I just want to make sure that the service is always working the best way that it can. For operating systems and for databases, I would probably use something more like Git Flow, because likelihood is other people are going to be using your code. People are going to deploy your operating system, they're going to deploy your version of a database, and they might have done some stuff which you've made way better in a new version, but they can't afford to bite off the complexity of upgrading to that new version right now. But they might have a bug that's pretty serious that you decide, you know what, they're a good guy, they're a good person, they're a good company, they give me lots of good business, whatever it happens to be, or there's just enough people on that version that it makes sense for me to go and fix that for them. And then you can go and you can fix that without interrupting or getting in the way of your ongoing feature development. What was the other example that you wanted?
Just like an
Application, again, the same kind of a thing. If it's an application that I can expect people to be upgrading, like if it was an iOS application, I'd be using GitHub Flow, probably, because I'm not going to be going and releasing a new version to the App Store of 4.2. I'm going to be releasing a new version of 5.1 or whatever it happens to be.
In the service scenario there, so we're kind of a place where we got a staging environment, maybe a QA environment, and then we got our developers working. Does that change the equation for using GitHub Flow? Is it, if I want to be able to put staging releases out there, or I just run those out my release branch?
It might. It really is going to depend on how good are you, how fast are you at getting stuff to those various environments. There's another workflow that I didn't cover today that kind of addresses that. It's kind of a mixture of Git Flow and GitHub Flow. It's called GitLab Flow, and they kind of recommend having maybe even a branch for each of your environments. What they don't really account for is, well, how do you get the code that you fixed on staging into wherever it belongs? That's something you'd have to come up with yourself. But in the past when I've had to deal with that, I've been using Git Flow, so it hasn't been that big of a deal because each of those environments is on some version. I'm not deploying a pre-release version. I'm not deploying something that hasn't gone through some kind of a release packaging step. So if there's a bug on staging, well, staging is 4.0.3, QA is on 4.0.4. If the bug is on 4.0.3 in staging, then I say, well, does it make sense to upgrade staging with the new version from QA? Do I do a support? Do I do a hotfix? Generally, it's going to be a hotfix. But really, that just depends on what can you get your IT group or what can you get your team on board with as far as where fixes belong, how we move stuff through that chain, through those various environments.
So in Git Flow, if I have a QA environment, which branch would I run that off of?
Well, do you want your QA people testing your development code or your production code? I've run it both ways. What I did at the last company was we had our production code running on QA because it was, we as a development team feel like this is ready to go to production. So we tag it, we ship it. Shipping it at that point means you give it to QA. They put it on their environments, and they're now running what I think is production. They're running my production branch on QA. If they think that it's great, then it just goes off to production with no further changes from me. The same tag is there. It's now just they're running the version that I delivered to QA. If there are bugs that they find that need to be done, then they'll tell me about it. I'll make a hotfix 4.0.4, whatever it happens to be. I'll fix those, make a new release, and give that back to them.
So if I'm running QA off of production, then the way I address an issue they find is a hotfix?
Yeah, generally. Because it's a fix to what you think should be on production. It's a fix to what you think the production-ready code is.
Because I don't think it was production ready if it's on QA. QA ready.
And that's where I get to, it really kind of depends on what your strategy is or what your philosophy is as far as where things go. If you don't think that things belong on a production branch until that's actually been vetted and trusted by QA, then what we've done there in the past at another company is we deploy to QA, the QA environment, that release preparation branch that I told you about. So we've gone there, we've bumped our versions, whatever. We think that it's ready to go, but we haven't taken that very last commitment step of pushing it and tagging it. So we run that on the QA branch, on the QA environment, and then when the QA team finds that there are bugs, we just add those commits onto that release preparation branch.
So in that case, QA is running on the release prep branch, and development needs to
It's kind of like a hotfix. The only difference is that you're not coming off of production, you're not doing new tags. You haven't tagged it yet. You haven't finished. You thought when you gave it to QA, 4.0.3 is ready to go. So I'm giving them this branch that I think they could just tag it and deploy it. They found a bug. I fixed that bug. That's still part of 4.0.3. With a commit, not a new branch. So I'm just changing, I'm adding to what I think is 4.0.3. And then when I've satisfied all their demands and made sure that everything is good, when I tag that and merge it down, those commits are going to still make it down into my production branch, because like we showed before, the way that that looks when you prepare a release, anything that happens on this release prep branch is ultimately going to get merged back into master anyway. So just like if it had been a hotfix branch that started over here and went back up and down, any of these commits are going to land down here. So I can fix their bugs without going to an extra hotfix branch or doing an extra version tag or whatever it happens to be. Basically, this branch is where you do everything that it takes to make that version ready for you to tag it as production. If that means you just bump versions and you give it to QA and you've already tagged it, great. If it means that you don't tag it until you've fixed all the bugs from QA, great. Anything you do there is still going to make it back to development.
It'd be helpful to know which branches are long-lived and short-lived. Like production up there, right?
You're right. I should have had an arrow going in and out of that one.
Now, is the release prep a short-lived branch?
Yes. The release branch is a short-lived. You create the release prep branch in order to make this one thing. Once that's done, this guy can go away. So, and I do have that called out on a separate slide, which you can look at later. But that's good feedback. I should update these slides to be a little bit more obvious as to which things stick around and which things don't. Other questions? All right. Well, thank you for coming. I appreciate any feedback that you'd like to leave for me so I can make this talk better for next time. If you go to Joined In, which this link just takes you to Joined In, you'll be able to get to the slides from there. I've got those all linked there, and any feedback you leave, I'll be able to see. So thanks for coming.